This video is one video from a series about comparing edge boards for computer vision. In a series of this video I compare board not only in terms of performance, but also from the side of convenience and simplicity for development. One video, one platform. All videos are available on my channel, and at the link in the description you can find a final table with different boards and the article about choosing logic of comparison. Today we will talk about Google Coral. I have had this board for 3 years now. I tested it a couple of months after the release, and I must say that 3 years ago and now in 2022, these are two fundamentally different boards. This story consists of 3 parts. In the first part, I evaluate Coral on a number of criteria that I think are important for machine vision boards. In the second part, I tell a couple of minutes the main development protocol of this board. And in the third part, I say something that didn't fall into the formal structure of first 2 parts. Let's start. There are 2 ways to flash the board, through USB and through SD card. I recommend doing it through the SD card, like this guide told you. Flashing is much faster than 3 years ago, but I found one problem and one inconvenience behavior. The problem is the instability of the Mendel development tool on my PC. I tried from 2 different Windows PC. On one of them the guide didn't work at all, and on the second I made a small tweak of this guide, and git bash didn't work also, but I use regular bash and everything worked well. The inconvenient behavior is the requirement to use the SSH key. It doesn't work smoothly on Windows. After key creation you don't know where the system creates this key, and I completely don't like to work with an SSH key and prefer to work with password authentication. But of course, it's cool when you work in a big company with a lot of devices. But when it's just hobby, better to use a regular key. It's minor problems. My mark is 4-star. The easiest of work. There were no problem for me. Regular SSH works well. No disconnect, everything is stable. Regular Python and regular packets are working well. 5 stars. How convenient the system. The Mendel Linux is forked from Debian. It's pretty conventional. Yes, I found a few very small problems, like non-working packets and a few different commands, but 4.5 stars and everything almost excellent. Community support. One of the most important characteristics of the board is how much the community supports the board. How many projects are on it, and how developed are the forums. It's clear that more information will allow you to solve your problems faster. My impressions is 4-star out of 5. Worse than Jetson and Intel support, but very good. Let's move to the models. The official model park is good. The models have a retraining procedure. You will not find any state-of-art and non-standard models here, but for most tasks they are good enough. I think it's 4.5 or even 5 stars. Let's put a 5 star. Unofficial model zoo. Google is actively developing the model infrastructure around Coral. There is tfhub.dev, and here you can find a few models for Coral from community. But here you can find a lot of TF Lite models that are pretty easy convertible to Coral. But you can check the community is here. You can look at Pinto Model Zoo. There are a lot of different models, and a lot of them are converted into Google Coral format. I think that everything TPU here is Google Coral. And even different project, for example, YOLOBY 5, they include Google TPU in a list of exports that are available from the box. Of course, not everything is supported. For example, the recently reviewed YOLA V6 is not supported, and of course, many of new models they're pretty hard to convert to Google Coral, but the situation is good. Let's point 4.5 stars here. How easy conversion of some random models. The situation is much better than 3 years ago, but it's still far from ideal. If your models is on TensorFlow or on Keras and it's converted to TensorFlow Lite, then with a high probability it can be converted to Coral. I tested 2-3 models that I used last months, and everything works well. But if your model is on PyTorch, then you will see it. I tried a few different models and they're not working. Of course, I tried the standard PyTorch or NX, TensorFlow, TensorFlow Lite, Coral converter. It's different converters, of course. It's clear that by trying some different approaches, for example, from Pinto Model Zoo, or by reading error logs and fixing them one by one, you will be able to convert almost any model. But this will take some time, and I am here speaking about how easy this process will be. So, of course, it's okay, but not excellent. I would say that I will put 3.5 star or 4 stars. Let it be 3.5. And let's talk about how easy to debug problems with conversion. As I said before, there are some logs and they're pretty good. And of course, there are a lot of community support, so you can fix almost every problem by using these logs. So I think that it's 4 stars. And let's speak about board itself. And let's start from processor speed. We will return to the TPU unit a bit after, but processor is pretty important thing when you work with computer vision, and there is no superpower here. This board doesn't have something like CUDA GPU, of course, and performance is pretty weak. You can look at my table at the end of this video and compare it with different board. It's not bad, but not fast processor. I get it 3.5 stars. But from mechanical structure and temperature stability, this dev board has a fun, but for me, even when I run the neural networks in the cycle continuous and stream a video, processed video on my PC, this fun turns off and on. It's turned on every 3 or 5 minutes for just 30 seconds, and it's drop the temperature a lot. So of course the a bit bigger heat removal system can be completely solved the problem of heating, but even in this construction everything look good. And speaking about construction and temperature stability, I think that it's 4 stars. And from construction I have no problems. The board has mounting points. There are many packaging opinion. The board available as USB, M2, PCI Express, and different. Not every of them have fun, but probably not every of them need it. The board is pretty easy to buy. You can purchase this without any problem. And pretty important thing for development or some hobby. The board has pins for external connection, like classic Raspberry Pi set of pins, and you can control them even from Python library, and everything work well. And let's speak about speed. When we speak about computer vision boards, the parts about neural network speed, of course, is one of the most important part. I tested YOLO V5 and it worked pretty good. 640 on 640 image gives me 200 milliseconds. The speed is without NMS part. And 224 on 224 gives me 47 milliseconds. I assume that this speed is pretty good to work with one or even with two cameras in detection mode. But note that the YOLO is not the preferred architecture for Coral. Of course, efficient net and efficient det a bit faster on edge TPU. I check efficient det with about the same COCA accuracy, and the speed was comparable with YOLO V5 speed. For example, efficient det with 384 on 384 input give me the same 200 milliseconds, and this efficient DAT gives pretty same accuracy like YOLA v5s. You can check everything in the table, of course. And to complete this picture, I test a few different neural networks. For example, classic SSD MobileNet V2 300 on 300 input gives me 15 milliseconds, and MobileNet V1 224 on 224 input gives me 3 milliseconds, and MobileNet V2 gives me almost the same speed. These speeds are important to compare this board with different boards. Let's move to the second part of this video. And in second part, I made a brief overview of what development process look like for the Google Coral. And the process is pretty general. First of all, you need to install Mental Development Tool on your host machine. And as I already mentioned, if you use Windows, probably there will be some problems. After that, you need to flash your Google Coral. Just look at the documentation and flash SD with latest firmware, and put this SD and in Google Coral, and Coral will flash itself. Third part, you need to set up Coral through your host machine. It's pretty easy and fast. After that, you need to decide. You can use already prepared model and choose them from Model Zoo, or you need to train your own model. If you train in your own model, you need to convert this model to Coral. After that, you need to write some inference code for model. Just look at the samples. There are a lot of them, some of them on Python, some of them on C++, and after you inference your model, you need some code around it to choose behavior after inferencing, and just run it through the SSH or some different way. Nothing special, just like Raspberry Pi or any different board. Let's move to the third part of this video. In this part, I will summarize everything and provide my feedback about the platform. In my opinion, Coral has come a long way in the last 3 years. From pretty strange board, it went up to the top 3 platforms in terms of usability and how easy the platform is for development. There are many options how to develop your program, your product, and I am sure that Coral developers have a clear vision of the future of the platform. For example, I'm really like the movement to TinyML and new Corals with pretty small control chip. I like the systematic approach to privacy, which makes it a bit inconvenient to work with, but it will move this board in the future, because everyone is concerned about privacy, and the Coral, I think they made more steps in this direction than different boards. Of the obvious disadvantage that were not spoken in this video, I don't really like the tie to the TensorFlow. If TensorFlow will stop its progress and development, as many people think about it, where will the platform go? I didn't saw the JAX support, or probably switch to PyTorch, and it's a very important question, and I don't know the answer. Where will be Google Coral in 2 or 3 years? At the moment, I didn't have any good production project on the Coral. For example, we have a lot of projects and products on Jetsons or on Intel or on different boards. So probably my experience is not full, but from my point, I think it's a good platform. If you find this video helpful, subscribe. There will be a lot of video like this on this channel. Probably I will make some small demo project on Coral and also wrap up it as a video. Thank you for watching. Bye.